Hello students, welcome to Educate. Today we are going to study Newton's laws of motion, NCERT textbook, chapter number 4. So you have already studied in basic level different type of laws given by Newton, like laws of inertia, then other laws, gravitation law, etc. So we will study them one by one. So let's see different types of inertia. So inertia, inertia is measurement of mass. Heavier the body, more the inertia. So inertia can be of three types. The first one is inertia of rest. This is tendency of an object to resist a change in its state of rest. Example, when a bus suddenly starts moving forward, people sitting inside tend to fall backward. You must have an experience of this type. Then inertia of motion. If you are moving and suddenly, suppose you are in bus and suddenly brake is applied or brakes are applied, in that case you will feel a jerk forward. So that is called inertia of motion, the tendency of an object to resist a change in its state of motion. When a moving bus stops suddenly, passengers fall forward. Then inertia of direction. Suppose you are sitting in a bus and bus suddenly takes turn like this, then you will feel a jerk in that direction in which initially you were going. So there is change in direction. So here inertia of direction, the inability of body to change by itself its direction of motion is called inertia of direction. When a moving bus takes a sharp turn, a person sitting in the bus experiences a force acting away from the center of the current path due to his tendency to move in the original direction. So, as I told you, inertia is the measurement of the mass. Heavier the body, more the inertia. Sorry. Now, next term is momentum. If you remember, momentum P is given by P equal to mv, mass into velocity. P is mv, it is a vector quantity. So P is vector, V is also vector. So here definition is given. Momentum of a body is the quantity of motion. It is defined as the product of mass and velocity, P equal to mv. If you write the unit, then mass will be measured in kg and velocity will be meter per second. So kg meter per second. Then Newton's laws of motion. So first law of inertia, as you know, an object at rest will remain at rest and an object in motion will remain in motion with a constant velocity unless acted upon by a net external force. That is simple. Then second law is important one. So here second law means change in moment. Generally we know that F equal to ma. So is it correct way to say that second law is this? So actually second law says that change in momentum with the time. So d upon dt of momentum is mv is proportional to applied force. If we take constant here, proportionality constant as 1, so what do we get? D upon dt of mv is equal to F, or m being constant, although m will also vary in different cases when speed will be relativistic. So later on we will study that. So m dv upon dt gives F, but you know dv upon dt means change in velocity with the time, so that is acceleration. So we can say F equal to ma. The same thing is explained here. The rate of change of momentum of a body is directly proportional to the external force applied on the body, and the change takes place in the direction of the applied force. Same thing is given here, F proportional to d upon dt of mb, where here we have put one constant whose value is generally taken as 1 in SI unit. So k, here k, and dv upon dt is acceleration, as I told you. So here we write as F equal to ma. So force equal to mass into acceleration. And now we write the different units of force. So you know SI unit is Newton and CGS unit is dyne. And you must remember the relation between CGS unit and SI unit. So unit is 1 Newton, here relation is 1 Newton equal to 10 power 5 times. Whenever you will do conversion from CGS to MKS or MKS to CGS, MKS means SI, so you have to know these values, otherwise there will be difficulty. Now, gravitational units are also there. 1 kgf, kilogram force. So kgf, this term is same as 9.8 Newton. So this can also be written as 1 kg weight. And the kg weight or kgf can be replaced by 9.8 Newton. Suppose 2 kg weight you are given. 2 kg weight. It means you are going to write it 2 into 9.8 Newton. Or 2 kgf is written, same thing. Now here, gram weight, CGS unit, gram force, so 980 dyne. If you remember, value of G in CGS will become 980. Now, here there is one question for you. A bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a heavy wooden block and it stops after the distance of 60 centimeter. What is the average resistive force exerted by the block on the bullet? So let's evaluate. Here you are given M is equal to 0.04 kg and here U is given as 90 meter per second and V is given as 0 because body comes to rest. And distance S is given as 60 centimeter, which is equal to 0.6 meter. Now, if you apply formula V square equal to U square plus 2AS, V is 0, U is given velocity that is 90, so 90 square plus twice of A is to be found, and S is given as 0.6. We can evaluate it. A will be negative, means retardation will be there. So minus 90 into 90 divided by 2 into 0.6. Here, if you want to remove this decimal, so multiply by 10 and remove this portion. Now, here 2 times 5, 6, 15 times. So you are left with A equal to minus 15 into 5 into 90. This is meter per second square. This is value of acceleration. Now you need resistive force. So you can write F equal to MA and then put the value of A, and M is given in our question as 0.04. So you will get the answer. Now here there is another question. If an object of mass 20 kg is moving with a velocity of 10 meter per second and on applying a force, its velocity changes to 20 meter per second in 2 seconds, then find the magnitude of the force. Here again, situation is simple. U is given as 10 meter per second, V is given as 20 meter per second, and time is given as 2 seconds. And you have to find out the force. Simple. So first you apply formula for getting acceleration. So if you remember, V equal to U plus AT gives V minus U divided by AT as acceleration. So V is here velocity 20, 10. So write 10 divided by 2. So it is 5 meter per second square. So you have got the value of acceleration. Now you need force. So F equal to MA. I think you have understood. Now, next question is, a constant retarding force of 50 Newton is applied on a body of mass 20 kg moving initially with a velocity of 15 meter per second. How long does the body take to stop? Here you have to find out the time. So F is given as 50 Newton and the mass of body is given F as 20 kg. So first of all, let's find out what is the retardation. And after that, we will see what happens. So F equal to MA. So F is 50, M is 20, A is to be found. So A will be 2.5 meter per second square. This is a retarding force, keep in mind, A will be negative. Now, A equal to V minus U upon T. Here, what information is given? Let's see. A constant retarding force of distance applied on a body of 20 kg moving with initial velocity 50 meter. How long does the body take to stop? So here, body comes to stop, it means V becomes 0 and U is already given. U equal to 15 meter per second and time is to be found, no problem, and acceleration we have got as negative 2.5 meter per second square. You can put these values here, you will get T. Put T here and then A here and then evaluate. So you will get 6 seconds. Here, there is another question. Question says, a rocket with a lift of mass 10,000 kg is blasted upward with initial acceleration of this much. Calculate the initial thrust of the blast. Here, see the question situation. Mass is given 10,000 kg. Acceleration is given as 10 meter per second square. Now question is, will answer be F equal to this 10,000 into 10? F equal to MA? No. In any case, no. Because you know, when suppose body is here, acceleration due to gravity will act in downward direction and its value is 10 meter per second square. Here net acceleration is 10 meter per second square. What does this mean? If we take total acceleration in upward direction 20 meter per second square and we reduce it by acceleration due to gravity, then we will get 10 meter per second square as net acceleration. So here, instead of multiplying by 10, we have to multiply by 20. So F will be equal to 10,000 times 20 Newton, and that will be our answer. In next question, a ship of mass 3 into 10 power 7 kg initially at rest is pulled by a force of 5 into 10 power 4 Newton through a distance of 3 meter. Assuming that the resistance due to water is negligible, calculate speed of the ship. So I think you can easily do here. Initially at rest, a ship of mass initially at rest, it means U is 0, V is to be found, and S is given 3 meter, F is given 5 into 10 to the power 4 Newton, and M is given as 3 into 10 power 7. So formula you can apply, V square equal to U square plus 2AS. Here our concern is to get V, U taking 2 is 0. Here what will you do? So V square equal to, this is 0, don't write, 2A. In place of A, just write F upon M and then S. You will get V square because F is given and this is F, this is M, so you will get acceleration. Here you will write and S is given, then you can evaluate. Next point is, a cricket ball of mass 150 gram moving at a rate of 20 meter per second is caught by a bowler in 0.1 second. What is the value of blow that he receives? So here what has happened? M is given 0.150 kg, U is given 20 meter per second, V becomes 0 because bowler catches it in, and time is given as 0.1 second. Now what you have to do, you have to find out force. So F equal to m times V minus U divided by T. You can put the values, you can get easily. V velocity, that is given, this is 0, U is given 20, and time is also given 0.1, and mass is given, you can put this value. Now let's see another concept, that is impulse. So impulse is force of short duration. Generally it is equal to change in momentum. So when it comes the unit of impulse, so we can write the unit of momentum, or we can say Newton second. So generally impulse is denoted as J, and it is F times T. If you analyze it further, so you will get same thing. We will see how, because Newton, and then you will write second unit. So we are going to analyze why J equal to change in momentum. So impulse is total effect of large force which acts for a short duration, and J is force into time, then total change in momentum, as I told you. Impulse is a vector quantity. It is, its unit is Newton second or kg meter per second. Now for measuring impulse, we can apply two techniques, either graphical method in which force and time are given. Suppose here this is force axis and this is time axis, and suppose we have this type of figure. So total impulse, if you want to find out, then simple technique is there. This is height, this is base, so this is a triangle, and area of triangle will be the measure of impulse. Here same thing is given, here graph is given whereby you can calculate the impulse. So here clearly from here to here total separation will be, this is 3, this 14, so 11, and this height is given as 10, so answer will be 15 Newton second. Now it may happen that force is not constant, it is variable. In that case, we will use the concept of integration. We will write the limits from where this force starts acting and till what point of time it acts, and then we can evaluate. We will see such questions later on. Now we can see some applications of impulse, like lowering hand by a cricket player. You must have seen, to increase the time, because F into T will be impulse. So when he lowers the hand, so time will be increased, thereby net force acting on his hand, means net blow, will be reduced by certain factor. When a cricket player lowers his hand, then this word is wrong, it's not there. When a cricket player lowers his hand to catch his hands to catch a ball, they apply, so either you make cricket players, in that case sentence will be correct, they apply a force to the ball over a short period of time. This action increases the time over which the force is applied, reducing the impulse experienced by the ball. As a result, the ball experiences less change in momentum upon impact with the player's hand. Okay, another, shock absorbers in automobiles. You know, shock absorbers are provided in all type of vehicles. Whenever there will be bumps, then impact of force will be less. Buffers in trains also serve the same purpose. Then China wares are packed in straw so that they may not get damaged. Then comes example number 2, in which a batsman hits back a ball straight in the direction of the bowler without changing its initial speed of 12 meter per second. If the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. So question is simple. Here ball is moving with 12 meter per second initial speed and final speed. It was moving in this direction and it then starts moving in this direction with the same speed, only direction is changed. So impulse will be final momentum minus initial momentum. So if you take it positive, it is negative. So this final is negative minus this will become negative, further negative. So double negative. So you will get the answer. Then comes, let's see one more question. Example 3, a ball moving with the momentum of 5 kg meter per second strikes against a wall. Ball is coming like this and it strikes here, then comes back with same angle. So here we have to take the components. One component of this will be in this direction and another component will be in this direction. For this, one component will be in this direction, another component will be in this direction. So what happens? So here sine theta components will cancel out and cos theta components will be left. So we can evaluate it. So total change in momentum will be due to cos theta component. Theta is given and momentum in the question is given. So you can easily evaluate. And here there are some more questions. So we will work on them in next lecture. I think you must have understood the concept of impulse. Thank you, Team Educate.